This video will discuss the brief notion of independence in terms of probability. We build independence from what we call the multiplication rule. The multiplication rule says that if two events A and B are independent, then the probability of the two events occurring, A and B, will occur in sequence is given by multiplying their probabilities. So essentially what that means is, if you have, remember we have Venn diagrams, let's draw a Venn here. So you have a Venn with event A and a Venn with event B. If event A and B are two independent events, then the probability of their intersection, or again, remember that's the and statement, the probability of this intersection right here, which is the probability of A and B, should be equal to, so the probability of A and B should be equal to the probability of A times the probability of B, if these two events are independent. And we're going to formally establish this when we talk about conditional probabilities, but right now, the thing you need to know that if two events are independent, what that really means, if you see this word, independent, this word just means to multiply probabilities. So here's an example. For ACL surgery, the probability that the surgery is successful is 95%. Find the following probabilities. The first one says that 3 ACL surgeries are successful. So on A, what that means is, if a doctor performs this surgery, he's 95% successful on any time he does the surgery. And you would think that one surgery should not affect another surgery, or you would hope that, just in general, that one surgery doesn't affect the other surgery, which means they're independent events. And if that is true, then, so here's what happens. You have 3 people that come in. You have a person 1, person 2, and person 3, all go in and get a surgery, ACL surgery. Well, each person should have the exact same probability of success, which is 95%. So that's 0.95, 0.95, and 0.95. Calculating this, because they're independent, we can just multiply their probabilities. And so this is just 0.95 times 0.95 times 0.95, or 0.95 to the third, which is 0.857, say 4, rounding in 4 places. So the probability successful with a doctor is successful with all 3, or that there's 3 successful surgeries, it's about 85.74%. The next question says, what's the probability that none of the 3 are successful? And again, now we're talking about none. So we know the probability of success, we'll call that P of S, success, is equal to 0.95. Let's talk about this probability of what we call failure. So if that's 0.95, the probability of failure is the complement of this, or 1 minus 0.95, which is 0.05. And technically, let's write this in terms of complement notation. Let's call this S prime, 0.05. So what we want to know is the probability that these 3 surgeries, so 1, 2, 3, none of them are successful. So that's going to be 0.05 times 0.05 times 0.05, failure, failure, failure. And again, they're independent, so we can multiply. So this is equal to, multiply that 0.05 to the third, and we get 0.0000125. Now, your calculator may give you that number as 1.25 raised e to the negative 4th. That's scientific notation. That negative 4 means when you write this, that number that they give you, 1.25 to the negative 4th, you're going to give it 1, 2, behind the decimal, you give it 1, 2, 3. The 4th spot is where you start your number at. So the last one says, what's the probability that at least one of the 3 ACL surgeries is successful? Well, at least one. Let's talk about what at least one means. At least one means that when you have 3 surgeries, what does at least one actually mean? Well, that means that you can have 1, you can have 2, or you can have 3 for the least one. What can you not have? So when we say at least one, is the probability that, we'll write it like this, at least one means X is greater than or equal to 1. And again, that's the probability that x is equal to 1. Or, so we're going to say plus the probability that x is equal to 2. Or the probability that x is equal to 3. So it's the probability of all these occurring. Well, who does that not include? Well, 1 success, 2 success, 3 successes. Who does it not include? No successes. So we can actually use the complement. And what we're going to establish here is that the probability of x being greater than or equal to 1 is actually equal to the complement, 1 minus, who are we not including? The 0 case. The probability that x equals 0. And so we could literally find the probability x equals 1, or x equals 2, or x equals 3, and add all those up. The simpler method, though, is to use this complement method and to say, well, we know that 1 minus, well, x equals 0 means that you have no successes, and that was actually calculated right here. This is the probability that x equals 0. And when I say x, I'm using a random variable, but I'm defining x as x equals a successful surgery. So like this first one would be the probability that x equals 3, because how many successful surgeries did I want? 3. This next one is probably x equals 0. Here, greater than or equal to 1 means that x is equal to 1. So we do 1 minus the probability of no successes, which is 0.000125. That's equal to 0.99875. So again, when you see the word independent, independent just means to multiply your probabilities. And if two things are independent, we're going to multiply probabilities. The other thing you need to understand is that when we talk about at least one, that's going to be a common theme that you're going to see a lot of. At least one means 1 minus the probability of none.